So we've already confirmed through the previous videos that the periodic table is really the quantum number table. We know this is the S block, 2 columns, the S orbital, the S sublevels made up of 1 orbital, each orbital holds 2. This is the P block. The P block. The P sublevels made up of 3 orbitals, each holding 6, and there's 6 columns here. This is the D block. The D sublevels made up of 5 orbitals, each holding 2 for a total of 10. There's 10 columns there. S block, P block, D block, and of course down here, pulled out of the table, is the F block. F block's made up of 7 orbitals, each holding 2 electrons for a total of 14. And we know that there's 7 horizontal rows or periods to the periodic table. But this is not the version that you'll normally be given. So how can you get Aufbau's order of filling without all this little 1s, 2s, 3s, 3p, all the little energy levels and sublevel combinations added up so that it's in order? Well, the periodic table is always in this order. When you look at a periodic table, it is in this order. Here is our periodic table. They do not have all the little S1s and all that on here. They don't have a lot of the other information on here, but you know there's 7 levels. That's the principal quantum number, 1, 2, 3, 4, 5, 6, 7. You know this is the 1s, this is the 2s, this is the 2p, this is the 3s, because when you get a periodic table, you can number 1 through 7 right down the side. You know this is the S block, 1s, this is the 2s. You know this is the P block, so that's the 2p. The main block, the S and the P, line up with the 1 through 7 that you write down the side. The trouble we run into is when we get to the D sublevel. The third level has the 3s, sodium and magnesium. It has the 3p, aluminum through argon. But the 3d is after the 4s, scandium through zinc, because of Aufbau's energy. The 3d has an energy of 5, the 4s has an energy of 4, as we learned in previous videos. So what do a lot of chemistry students do when you're given this version? Above the 3D, they write n-1. They write this on their periodic table, n-1. So they'll number 1 through 7 down the side, and then they'll write n-1 here. This is n. 4 minus 1 is 3. That's the 3D. 5 minus 1 is 4. That's the 4D. So a lot of students, all you need to do to know Aufbau is you need to know this is the S block, P block, D block. Down here is the F block. You don't need this version of the table because you can fill this version of the table out on any periodic table you're given. They write n-1. Why do they write n-2 above the F block? Because this is the 6s. The number corresponds there. This is the 6p. But this is the 5d, n-1. 6 minus 1 is the 5d. Why do they write in n-2 above the F block? Right here, n-2 above the F block. 6 minus 2 is 4. The 4F gets filled after the 6S, again because of energy. When you're in the F, your second number is a 3. Four plus 3 is 7. The 6S is energy. When you're in the S, your number is a 0. 6 plus 0 is 6. 6 is lower than 7. So the 6S gets filled before the 4F. But I don't have to remember that. I just write in n-2. I write a 6 out in front of that row. This is in front of that row. You see how it breaks out? 6 minus 2 is 4. This is the 5F. 7 minus 2 is 5. What about all these little numbers? They're not on a normal periodic table of elements. They just give you the group numbers on a normal periodic table of elements. These are your group numbers right here at the very top. Kind of useless, really. Just a fast way of referring to it. Hey, I'm talking about group 14. Oh, you're talking about carbon, silicon, germanium, tin. That's group 14. The Roman numerals are not useless. These Roman numerals, if you remember, are giving you how many electrons they have in their valence, the outermost energy level, your biggest N in your electron configurations. So where can we get these S1, S2s? Well, this is the first column of the S, that's S1. This is the first column of the D, or that's the second column of the S, S2. I can't fill here until this is full. I have to fill the 2S before the 2P. So there's 2 in the S1 and the P. Carbon has 2 in the S2 and the P. It just goes straight up. 2 in the S3 and the P, 2 in the S4 and the P, 2 in the S5 and the P, 2 in the S6 and the P. 2 and 6 is 8. 2 and 5 is 7. 2 and 4 is 6. 2 and 3 is 5. 2 and 2 is 4. 2 and 1 is 3. There you go. 2 is 2. 1 is 1. These Roman numerals, as we mentioned, are the really right up through here. They are the numbers of electrons in the S and D. There are some circumstances here that we probably won't even address this year. That this is S2D1, S2D2, S2D3. Then it goes to S1D5. Still 6 electrons. But that's not really significant for right now. So this one, you could, if you put S2D4, that would be okay for now. But 1 from the S moves over to the D. That's not a big thing that we're going to talk about. S2D5, S2D6, S2D7, S2D8. Then this should be S2D9. But for reasons we won't talk about, 1 goes from the S to fill the D. So 2 and 8 is 10 electrons. 1 and 10 is 11 electrons. And then it's S2D10. Once putting these numbers on is not essential down here. These numbers above do help you when you're doing electron configurations. But the big thing with electron configurations is knowing that you're going to write the 1 through 7 down the left side. This is the S block. This is the P block. For the S block, these numbers line right up with what sublevel is being filled. That's the 4S, 5S. Here's a 4. That's the 4P. You just have to remember P block, S block, D block, F block. That's really all you have to remember. And then N-1, N-2. You'll see chemistry students doing that all the time. Some of the idiosyncrasies that you see in the orders of increasing here are not vital. They are just exceptions to filling things. Really, they're not exceptions. They're special cases of Aufbau. Aufbau always says lowest energy first. Those special cases are not really relevant to where we are right now in Chem 1. So here's some interesting things about looking at the periodic table of elements. Some tips and tricks to doing electron configurations. And now we're going to talk in our next video about doing electron configurations. We'll be taking a look in our next video about our practice problems. Right here in our note packet, we're going to go over how to do these practice problems. And if you want to fill those out in your note packet as we go over those, we can. We'll look at 4 examples.